I'm Sebastian Oppenheim, and we're here with Professor Little, who is a marine botanist. He's going to be talking about these beautiful life forms and how important they are to the ocean. Professor Little, could you tell us a little bit about what you do and how you do it?
My interest is primarily in seaweeds, although that's only part of the primary producers, or the algae in the ocean. So the seaweeds are the ones that grow in more shallow waters, coastal waters, because they're attached to the bottom and they need to have sufficient light to carry on.
Do seaweeds produce oxygen? Are they like regular plants? They take in CO2 and
they take in
emit
CO2 and produce carbohydrate, and in the process of producing energy that will drive carbon fixation, the seaweeds are producing oxygen as a byproduct. Yeah.
So seaweeds are a very important part of the ocean.
Extremely important, yeah. What's interesting about them is that they can grow in the intertidal, and some of them grow very, very high up in the intertidal. For example, in the Bay of Fundy, the average intertidal distance is 28 feet. Wow. You'll find seaweeds way up out of the water for several hours. So some of them are able to withstand drying for many hours, and so that's a very special adaptation. So they're almost terrestrial in that sense. So they go from the high intertidal down to the deep oceans. The deepest seaweed that has ever been documented to carry out photosynthesis is at 600 feet. Wow. Most people would say there's no photosynthesis at that depth, but that has been proved.
So seaweeds are very important to biological life. How does chemical pollution affect the organisms, and I guess particularly algae or seaweed?
A lot of chemical pollution is simply nutrient runoff, nitrates and phosphates and things of that sort. Some seaweeds are more adaptive to that than others, and so they will take advantage of it. So some seeds will overgrow. Some
of the seaweeds overgrow because of the excess.
And they will, if they overgrow, they will also use up oxygen. So they can actually cause a decrease in oxygen in the area and so on.
What about the dead zones in the ocean? You know, the dead spots where absolutely nothing is living.
A lot of these areas where there are no seaweeds at all, and maybe no other organisms at all, a lot of the areas where there are no seaweeds are kind of puzzling. For example, I work in the tropics a lot, and in the tropics there aren't very many places where you see a really large community of seaweeds. And a lot of that is because of very high grazing pressures. There are a lot of herbivorous fish and so on. The organisms are there, it's just that they're grazed down and they grow out and they get grazed down again. So that's one thing. But there are also other areas, I work in Thailand a lot, where there are solid substrates, the conditions would seem very good for seaweeds, but you don't see a lot of them. We don't know exactly why that is true.
Well, I mean, have you heard of the dead spots in the ocean?
Yeah. Dead zones that I've heard referred to are conditions where there's no oxygen, and that often is due to pollution. One of the other issues about sort of related to pollution is introduced organisms. Because a lot of the barriers that we have, natural barriers like the Great Wide Ocean, have been passed through ships and so on, so that they're bringing organisms from one place to another that in nature would never have occurred. And this has been going on for a long time. Those introductions are very significant because they don't usually have predators. So they are free to grow without any kind of balance keeping them. These are, as I mentioned, these are what we refer to usually as rockweeds. They're growing attached to a solid substrate. This one, some of the other types of seaweed, this is a red alga which would be growing deeper in the intertidal, maybe in the intertidal, but in the subtidal, and so it wouldn't survive being out of the water at all. All these seaweeds have very different life histories from higher plants. Higher plants almost all have the same life history, whereas seaweeds have a huge variety of different types of life histories.
Is this an example of how the
What they
life
attach to.
forms, other life forms attach to
The substrate.
seaweed?
This is just a little shell. If the seaweed gets really big, it'll just move the shell.
Yeah. Do
around.
do they have a symbiotic relationship?
No, it's just attachment. This seaweed can get to be very large. It can be 2 meters in height. This is just from Botany Bay, right here. So you can see there's a lot of variety in the morphology of the
And this is
seaweed.
only on Long Island?
Only Long Island.
So there is a lot of variety.
A lot of variety. Some seaweeds, as you know, are edible.
Mm-hmm.
For example, this is an edible seaweed. In New England, it's called dulse.
Would they be able to replace food one day, do you think?
A lot of people tout the nutritional value. It's mostly, I believe, in the minerals that they have. The seaweeds have a very good balance of essential minerals.
So not caloric, but mineral.
Not caloric, and maybe not so many vitamins, but more of the mineral content, which is becoming more and more important in our diets because we have so much processed food that the minerals are usually what are leached out of processed food, or we cook things too much or something like that.
While you're in the United States, do you have some in your kitchen right now?
Oh yeah.
Yeah?
Yes.
Is it the type of sushi seaweed?
I can show it to you. Oh yes, I always have seaweed. These put things in attractive containers.
Yeah.
They also put...
So what's the best kind of seaweed to eat?
Well, I think one of the useful seaweeds is nori, which is what we use a lot in sushi. For example, a typical Japanese breakfast, you would have rice, and then you would put egg on it, raw egg, and then you would take a piece of the and some soy sauce, and you take a piece of the seaweed and wrap it over the top of the rice and the egg and make like a
sushi
ball
roll
of it.
kind
Yeah,
of,
like a sushi roll of it.
Oh, yeah.
It's very common. If you in Japan, you would probably eat seaweed almost every meal.
Really?
Yeah.
Do you mind if I try a piece?
Oh, sure. No problem. It doesn't have a great taste just by itself.
I've only ever had the sushi kind, so...
This is the sushi kind.
This is the sushi
Yeah, go ahead.
Would you like a piece?
Sure.
It's kind of like fish food, right?
No, I don't. I think it tastes pretty good.
Well, thank you, Professor Little. And not only is algae beautiful, it's a very important part of the ocean's ecosystem.